Hey, guys, how you doing? Is everything going well there? So yeah, I was here just relaxing, doing my stuff here for relaxing me before starting the class. I'm so happy that we are here at the live class, ROS Developers live class number 30, already number 30. And I'm back again since some classes that I was not here and my colleagues were doing the hard job and very well job. And now it's time to me to come back actually and to start doing again nice live classes. So as you probably know, we are going to dedicate 3 live classes, the next 3 live ones, to the Duckietown project. So what we are going to see is how to program the robot of the Duckietown by using simulations, Gazebo simulation. So as you probably know, because the Ducky robots, they are based on ROS. So if we achieve to program them inside another environment, another scenario that has the same ROS API, then we can transfer the programs to the real robots. So we are not going to use the official code of Duckietown. So you can go to the web pages. I have put some links beneath on the notebook that we are going to see today to the official information. So you can check it later. Here we are going to develop the whole thing by ourselves. So we are going to use Gazebo simulations and ROS code that we have developed. Okay, but the results that we are going to obtain here, they can be applied to the original Duckietown and the AI do competition. Okay, so let's start. I see here some people that was already asking questions on the chat that we say if we are going to see how to submit our solution for the competition. I'm sorry, but we have to say that we are not associated with Duckietown organization in any case. So in any sense, so we're just showing how to use ROS to program those nice robot in a nice project. So that's what we are going to do. Let's go. First thing is to share the project with you. So what I'm going to do is to, as always, go to the projects for today and then share it with you. So let me first share my screen with you. So here it is, where it is, here, share. Yeah, so first, let's go here. I have here the Duckietown live class number 30, and I'm going to share the project with you. So that is the link. And as you probably know, this is very long for the chat, so I had to use the Google to simplify the links. Shorten, and then I can post it easily in here in the chat. So I'm going to put it on the chat right now. And there it is. Then, as always, click on the link that I have put it on the chat. And then this project, this ROSjet that we call ROSjet. So this ROSjet will be copied to your ROS area. What is this area? It's called the ROS Development Studio. For those of you who doesn't know, it's a development environment online where you can develop for ROS without having to use to install anything in your computer. And you can use a Windows machine, a Mac machine, anything, and do some cool things like this one, like sharing the project with other people. So whatever I have created for this project, then you will be able to run it. Okay, so I assume that everyone has copied this project by clicking on the link. Now it's time to open it. So press the Open ROSjet button, and let's go to the machine. So you will have here this desktop that is empty. And the first thing that we have to do is to open the notebook. Let's go to Tools. And then here we have Jupyter Notebook. So I have included here a notebook that is for this live class. Okay, so it's here the live class number 30. And if you press on that link, you will see that it appears here, the notebook. Let me put it a little bit bigger so we can see. And it's about this live class. Okay, so let me tell you that this notebook has been created by Epson Worko and by myself. And so you can use this notebook as you want. So you can distribute it, you can copy, paste, whatever. Do whatever you want. And this class, as I mentioned, it's the first of a series of the Duckietown Driving Olympics. So in this one, we are going to see the simulation, the robot interface for that simulation, and a few programs, how to use it. And then on the next one is when we are going to start using OpenAI for training the robot to follow lines and do more cooler stuff, okay? So these are the prerequisites that you need to be quite a little bit familiar with ROS, okay? So we are not going to start explaining ROS here. And what contains this ROS yet, here I haven't described what it contains. So is this notebook? Then it contains the Duckietown simulation for Gazebo. That includes the city, the bots, and the roads and traffic lights. And then we have a fake navigation package that is used to make the robots navigate around the city in an autonomous mode. Okay, so what I would like to mention is that, as I said at the beginning, we call this kind of project, we call it a ROS jet. And then here I have attached a video that you can see how to create your own ROS jet. In case that you want to create things so cool as this one, then you can do it and distribute it by yourself. It's for free, of course. And here is a video, but let me tell you that also tomorrow, Wednesday, we are going to have a webinar about how to create ROS jets. And here is the link to this webinar. So it's about how to create ROS jets and how to distribute it, how to share with your peers, students, and make others reproduce your results without having to install anything. Okay, so let's see about this material. Yeah, so here we have a direct connection to the video. So how I am activating those videos, sorry for the new people, is just selecting this cell by doing a click, and then you can press play here, and then it executes the code that is there, so it will show the video. And the same I have done here. So you select this and then press play here, and then this is a video of the actual thing that we are doing now. Okay, so you can watch it later. When everything is finished, this session, this live class will be recorded, and then by pressing play here, you will be able to see it. Okay, so what are we going to see is the Duckietown simulation. How does it work? How the interface for the Duckiebots, it's working on the ROS. And then we are going to see a little bit of the autonomous navigation and how to launch several robots on there. Just a few data about the Duckiebots. So here you can see a description of the components. And actually, if you go to the actual website of the Duckietown, you will see a way of buying all this material and be sent to you. So you can build your own real Duckiebots and use them in reality. In this case here, we are going to use the simulation. And then everything that we create here, since it contains the same interface as the real Duckiebot, every program that we create here will be applicable directly to the real robot. Here it's just small information about the names of the Duckiebots, how the creators of the project are calling them, and you can provide those names, for example, to your bots when you launch them here in the simulation. So if you have many of them, then you need to provide a name to each one of the robots that is simulated. And you can use this convention here. And here is Duckiebot number 17. And then you can provide those extra flags indicating if the robot has a wireless adapter, if it has a wireless joypad, etc., etc. So those are examples. Okay, so let's go to the simulation. And the simulation of the Duckietown. Then for this simulation is already included. And let me show you where it is, just in case that you want to have a look and modify later. So if you go to Tools, and then you go to IDE. Okay, so yeah, that's a message because I was working on another project previously. So it's detecting that I don't have the files. That's okay, no problem. So let me put it here and a little bit bigger so you can see better. And here, so we have 4 directories. Okay, the ones that we are going to use today is the notebook workspace, is the one that contains this notebook that you are seeing here. So that we are experiencing here. So it's contained here as a Jupyter notebook. Here is the data, and the images contains, etc. So that's okay. Then here we have the simulation workspace, and here is where we have the actual simulation of the Duckietown, including the Duckietown. Duckietown description actually contains the robots description, and then the Duckietown Gazebo is the one that describes the world, the whole city. Then I recommend you to have a look at our previous live classes about Gazebo and how to organize these things and how to create simulations, etc. Let me remind you that you can ask me questions at any point in time. So you can just go to the chat and ask me questions if something is not clear, you are not following, or you are having trouble opening the notebook or whatever, compiling or whatever you have to do. Actually, we don't have to compile today. Well, so that's where the simulation is located. Okay, so this is the simulation workspace. And then we have also the Catkin workspace that contains a package that is called the fake navigation. This fake navigation is a package that we have created for making the robot move autonomously around there in a predefined sequence of points. We'll see in a minute. Now, so this is the simulation, so you can download it, use it in your own local computer if you want, and launch it because it's just ROS packages for Gazebo Simulator. So everything that we provide here, you can use it locally and do whatever you want. And have a look at the packages later if you are interested in seeing how we have created the simulation. Now, what we are interested is into launching it. So for this, let's go to Simulations and then select the launch file. So you can also, before I select that one, you can also launch any other simulations that we have here already predefined in the ROS Development Studio for different robots. But in this case, we are going to launch from the simulation workspace. This means a specific simulation that we are creating in the ROS Development Studio. It's not one of the ones provided by the environment itself. So it's our own simulation. So go there, select Launch File. Then here in the Launch File menu that it will appear, select the Main Launch. Main Launch, and then press Launch. And a new window should appear here for you. Let's put it here. And after a few seconds, then it will appear here, the simulation of the Duckietown. Starting to appear something, to have movement. Let's see. There is a question by Subhash Das that says, are those workspace simulations similar to Duckietown? I don't understand your question, Subhash. I suppose that you mean yeah, so I see your second part of the question. Or we are making this independent from the Duckietown project. Yes, this is completely independent from the Duckietown project. I'm sorry, but we don't have any relation with the Duckietown project. And we respect it very much, and we think that is a super cool project, and that is why we have selected to show some interesting things here in ROS. And also, whatever we learn here, you can apply directly to the Duckietown project, because after all, everything is a ROS package. So you can create it here or in your local computer and then apply to the real Duckiebot or the other simulation that the Duckietown project has, if they are maintaining the same ROS API, that I presume that they are, because it's the logic way of doing it. Okay, so here is okay, so it doesn't show. That's a strange. It says simulation running, but it's not showing. Here, let me check if we have everything okay. So here I have launched. That one is the Gazebo, yeah, main one, and the meshes, yeah. Okay, so yeah, for some reason that didn't work. Let me try it again. I see is, yeah, so is this one correct? Let me see. Okay, so we are relaunching this simulation. Relaunching is as simple as this. So you go here and then you relaunch, and then the whole system will take care of closing everything, killing Gazebo, opening it again. Here it is. So I don't know what happened. We should investigate that issue, but that will be after the class. Now, let's go and see the simulation. So you can see here that we have the simulation. It's an example of a village. So you can have different configurations and you can put anything in there. Then what is interesting here, well, is the different roads, also the intersections. And here we have included a couple of traffic lights, trying to simulate the traffic lights that the Duckietown project creates. So it's green and it should turn to red. Okay, so we are going to see that about turning red and green on the third live class, because that will be useful for a driving thing. And for driving, for controlling different situations when the intersections have to be dealt by the robot. So we have one traffic light here and another one here. Okay, and then we have a lot of ducks around there, but they are just a dread zone, so they are doing nothing. And the interesting thing then is where is the Duckiebot? Okay, so there is none. By launching the main.launch, you will get no Duckiebot. Then in order to launch, then you have to do something special. It's another command. So we have separated this because you will see it's more convenient, because by separating the environment of the simulation and the spawning of the robot, we can achieve more control. For example, creating in an easy way, we can launch more robots when we need it, or just launch one robot when we only need one and then practice with that, so the load will be easier and we don't have to reload the simulation in any of those cases. Okay, so let's go on. Let's spawn one Duckiebot. So there is the command in the notebook. You can see it. And then I can tell you that by launching that command, the robot will appear here in this area. So if you want to see how it appears, then you have to take that specific location in your. And then let's go to the command. Let's copy this. And then we have to use the tools. We need a shell to launch the command, okay? So like in a normal computer when you have ROS, of course. So let's open a shell, and that's a shell. Like if you were using the Terminator shell, for example, in Ubuntu. So that's the same. So I have copied the command and I'm pasting here. And it says ROS launch Duckietown Gazebo spawn Duckbot.launch. So if you launch it, then you will see that the robot will appear here. And we have a comment here, Subas, yes, thanks for the explanation. And Subas, I just used RDS for the first time. It's awesome. Okay, thank you, Subas. Yes, we are working hard to make it awesome for all of you. Okay, so thank you for the comment. Here we have the robot, the Duckiebot. Okay, so, and it contains basically, it contains the camera and then the differential drive. And we have also added an inertial measurement unit, just in case that you would like to include it. But I think that the official Duckiebot doesn't contain that. I'm not sure about that. Anyway, the simulation has it, and you don't have to use it. We are going to keep moving only on the camera control here in this live classes. Okay, so I suppose that you have the Duckiebot. Let me know if you don't. If you don't have the Duckiebot, they're running. And of course, let me open another shell. Actually, we can close that one, but I'm going to leave it and just have another shell. We can do a ROS topic list and get all the topics that we have for controlling the robot. And there is one that is called odometry robot 1, and the jointer states and IMU data. And also we have all related to the camera. Okay, so image row, compressed depth, etc. So everything about the camera is there. And finally, we have the command bell topic. So here is where we are going to send the velocity commands to the robot. Okay, so you can see that all the topics related to the robot, they do have this robot1 prefix. So that is the name of the robot. And that's is required, is very useful, because when you have several robots moving around, then everyone will have its own command bell topic. And if you don't put the name of the robot at the beginning of the topic, then there will be a collision between all the robots that are listening to the command bell topic. And so that will be chaos there, and also funny to watch. But yeah, so if you try that sometime, you can record a video and show that to us, and so we can laugh a little bit. Great. So we have there the topics for that. And well, here, yeah, you know that this one is the one for the command bell. Let's verify that the camera is running. So in order to see what the robot is seeing, you have to launch this command. Here is the typical command from ROS. So I'm not showing you anything special. The only thing that you have to take into account is that the image topic is the proper one, but it's already prepared here for you. So here I'm going to paste that command, ROS run image view, image view. That's a typical command of ROS for watching images being published on a topic, okay? So as you can see, there is nothing here that appears, because the ROS run, the image view package, generates a new window with the camera information, okay? So in order to access the windows that are generated in a new window, so the programs that are generated in a new window, we need to use the graphical tools of ROS.ds. And for that, let's go again to Tools and select Graphical Tools. So if you select Graphical Tools, then here we have the application of the image view with the camera visualization. So you can make it bigger if you want. You can put in full screen, and yeah, so like this, for example. Okay, so we are going actually visualizing the view of the robot. That is this. Even if the resolution is not very good, you can tune the resolution components of this image on the plugin of the robot. Okay, so if you go to the simulation of the camera of the robot, of the Duckiebot, and then you check where the plugin is being created, then you can check, you can tune those parameters of the plugin for the camera and then make it have a better resolution, for example. In this case, we try to mimic the resolution of the camera that the real Duckiebot has. Okay, so far so good. So we have seen how to launch the simulation so far, how to launch a Duckiebot, how to see that the control API, taking into account the name of the robot, and how to see the screen for the images. So everything, it looks like, is working. So let's move forward. Basically, in this chapter here, we are setting all the tools that we will need later to do the interesting thing. That is going to be on the second live class. Sorry, guys, but we cannot do everything on the first live class because it's too much. It's too much. Okay, so yeah. So here is an example, to move the robot and see that check that the topic is working. So let me crash this, the image view, and let me copy. So if I copy this command and paste it here in the shell, then the robot, the Duckiebot here, should start turning. And it's not turning at all. Then yeah, that happens to me all the time. And you know what is happening is that the simulation has started in pause mode. So you can see here that is in pause mode. So if you press here play, then the simulation will start actually computing the physics and receiving commands from ROS topics. So let's press it, and there it is. So the command is being accepted, and now it's executed, of course. Yeah, that error happens to me, and sometimes I'm looking at the code, what is happening, and then at the end it's just the simulation post, So what can I say? Well, anyway, so that's moving. Okay, so now let's go for the more interesting part, that is the launch of the fake navigation. So let me show you the code of the fake navigation that is included here, as I mentioned, in the Catkin workspace. So how does it work, the ROS Development Studio organization of the files? Okay, so we have organized the files in 3 different workspaces. Okay, the notebook, is the notebook that contains this information here. So whatever you write here or you modify here, it will be saved here in the notebook. Okay, that's okay. But then about the code, we have in ROS, usually we have 2 different things. First thing, it's the simulation stuff. So it's about the simulation of the robot that you are using for trying to create your programs and test them before using on the real robot. That's all the packages of ROS that are related to the simulation. They should be put here inside the source directory of the user simulation workspace. And then why is that? Because everything that is related to the simulation is not going to go to the real robot when you want to transfer the code developed here into your real robot. So you should not confuse the packages of the simulation with the code that will go into the real robot. Okay, so whenever you have something related to the simulation, you have to put it here. The simulation workspace is a workspace for the code that doesn't go into the robot. Then all the packages that will run into the robot, they should be on the Catkin workspace source. These are packages for controlling the robots, and checking the images and processing them, detecting people, navigating, etc. Those are the packages that will go into the robot, and those have to be here in this simulation. By doing this organization, you're going to be free of many errors. So please follow this, and that's what we have done here for the fake navigation. Before I explain about the fake navigation, let me see that there are some questions on the chat. Here it says, Suba says, what is the alternative tool of that graphical tool? I don't understand your question. Then I see that you have something below. Then I mean, if I want to view the camera image in my local machine, okay, that's a good question. Yeah, so you have to do nothing if you want to see the image of the camera. And if you launch this command in your local machine, ROS run image view, then this window will automatically appear in your local machine on the screen. So you have to do nothing. But this is not possible to be done into a web interface. So that's why we had to do this trick about the graphical tools. Okay, but everything that we are running here, everything that we are creating here is directly applicable into your local machine. I don't recommend you to do that because this is so convenient to do it here online. It's so easy. Everything is set up, but you can do it without any problem. Then we have another question about Jorman Perez. He says, my robot is not moving. Can you please repeat how should I do it? Yeah, sure. Very quickly. Okay, so first of all, Jordan, you have to check that the simulation is not paused. So you see that now if I press this pause button, the robot will stop. Okay, so you have to be sure that display, so that the icon here has this shape. That means that it's running. Okay, and also the real time and simulation time, this is moving. Okay, okay. Then next thing is that you have to send the command in order to move it. And the command was, let me see here. It's here. So you just copy from ROS topic pub, all that. Then you copy that command, and then you open a shell here in the tools, go to tools, shell. Then here on the shell, when the prompt appears, there it is. Then you paste the command. Remember that you don't have to put this character here, okay, in the of the command, just from ROS topic, okay, and everything. Just copy like this, paste here, and then press play. So in my case, I'm going to change this. So I'm going to change this to 0. Oh, sorry, I pressed the wrong button. So I'm going to paste again, and I'm going to change this to 0 in order to stop it. So let me send it. Yeah, and my robot stopped there. Okay. And okay, yeah, but it has a small movement forward. That is why it's still moving. So I have to go very quickly and relaunch it with a 0, because otherwise it will get out of the 0 there. Okay, there it is. Stop. So Jordan, tell me if you are achieved to move. If you have achieved to move the robot. Okay. So in the meantime, let's continue. ROS fake navigation start. So before we launch that, let me show you the packages here. And it's a package in Python, so you can check. It's not difficult code. So let me put it bigger. So it's not a difficult code, and it's very simple. So basically, what it does is to connect. Okay, Jordan is running. Great. Perfect. Then what it does, this program, the fake navigation, is to send to the command belt topic of the robot velocities according to the next waypoint. So we have created here, we have identified here a series of waypoints that are put here in this trajectory. So those are points in XY coordinates of the whole city. Okay, let me put it here bigger. Yeah. So here, I don't remember where is it, the 0 of the Duckietown, of this Duckietown. But anyway, so what we are doing is we have identified several waypoints, and this program, the fake navigation, is sending to the robot to those waypoints one after another. So first it will go here, it will go here, then it will go here, then it will go here, then here, etc., etc. So we'll move like this, going like this, like that, like that. And it's a predefined trajectory. It's a predefined, so you cannot modify that. So the robot, it will be moving all the time along the same trajectory around, but it's quite enough. So it's enough. Why? Because we have devised 3 possible situations. And yeah, so for use it of the fake, let me show you, it's around here. Yeah. So for example, the fake autonomous navigation, it's useful if you want to capture images in an automatic way for training. So you leave the robot moving around, and then you play with the things. Maybe you move things around or put other robots around. And then this robot that is moving autonomously will be taking pictures and storing into a ROS bag, for example, that you can use later for training. Another thing is that you can let the robot move by itself while you are testing your detector. If the detector is working, then you can do it while the robot is moving. Actually, it's not only by ROS bags. And also you can use this fake navigation in order to launch other Duckiebots to move around. So your Duckiebot is the one who has to handle the interaction with other Duckiebots that are moving around. Then in order to launch the fake navigation, we have to launch this command, ROS launch fake navigation start. So let's do it. Let's launch the navigation. And I don't know, this one, for example, here. So if I launch it, then the program will send the robot to the first point, not in the sequence, but the one that is closer to the robot itself. And actually it's doing something very, very strange. Okay. Okay. So it's doing something strange. I don't know. It shouldn't do that. And let me see. I'm going to pause the simulation. Go here. and those things happen, you know. So let me move it backwards and turn in. I think it has to go in the other direction, but okay, so maybe we have to review the, let me close also the, whoops, sorry, I pressed the wrong, the address. So let me press here Control C, and then let's try again. Okay, so let me see. So, okay, yeah, so I had to press play on the simulation here again. Okay, yeah, so it's turned into another place. Okay, wait. Okay, let me see. Let me move it. So I don't know what is happening. Okay, so whoops. I'm going to try to move to another place. Let me see. Like that. And then moving forward. Okay, sending to a point that is the number 15, it says. So let's see, you see it says, the closer trajectory point to the Duckiebot robot is this one, which is the trajectory point number 15. Okay, so this program, what it does is detects the current position of the robot and then figures out which one of all the trajectory points that we have recorded, which one is the closest one to the robot. And then it sends the robot to that point. But it shouldn't be that one. I think it should be number 13. So I have moved it closer to the number 13 now. So let me launch again the fake navigation. And let me also press play here. There it is. Okay, number 18. Okay, so it was number 18. Okay, yeah, so now it's going there. Okay, yeah, so number 18, it was around here. But I think, oh, yeah, maybe it's, okay, yeah, I touched something. He's moving around, yeah. So I touched something on the last minute, and please never do that. Never do that, because it's a bad idea. And it was about the calculation of the speed, of the incremental speed here, of the speed that we have to use in order to move the robot around. So in this case, it was like this, and it was times, so I don't remember exactly, but I think it was 2 times the base speed. Let me check. Okay, so I'm testing. So I'm finding the errors in real time. So let's see. I'm going to do this modification. Let me test it, and then if it is working, then I will tell you how to do it. Unless if you are following with me, then it's perfect. Also, let's see. Okay, let me move it here, and let me leave it like that. And now relaunch again the navigation, fake navigation. Okay, so there it goes. Okay, I have to press play here on the simulation because I paused it in order to move it. Okay. No, okay, so something is really wrong. Okay, so I don't understand now why it's not been detected properly. Okay, let me see. There it is. Number 0. Number 0 should be here. And basis speed, yeah, so that's the basis speed. Then there is a routine that is checking how the difference between the position of the robot and the distance to the next point. So let me see, how can we check that? So here we have, let's see, here we have all the points here. And there are, yeah, like many points, yeah. Okay, then let's see here, see if the main loop is here that initializes the node, waits for the service, and then calls this speed publisher that we can directly go to the definition here. By the way, you can go to the definitions on the editor by pressing Control and then pressing on the function. So you will go to the definition of the function. Okay, in this case, this is this class that is doing a proxy to this service system and is subscribing to the command bell of the robot with robot name, of course. And the robot name has been initialized when we create the class, and it's called robot name here. And if we don't provide any robot name, then it will take robot 1 by default. This is not explained here, but is explained here in the launch file. This is something that I wanted to explain you later, and I will explain you later once I solve this error. Okay, so let's see. Because the fake navigation is very interesting because you allow the robot to move around. It's super convenient, it's super easy. Okay, so let me see in a couple of minutes if it is solved. Otherwise, I will have to check for the next class, and we will continue with the rest of the notebook, okay? So let me see. Then we were here at the beginning. Then the trajectory we define. And next point, next trajectory point, it's the get closer trajectory point. That is defined here. And then basically what it does, this one, is to compute the distance between all the points of the trajectory that we have defined and the current position of the robot. That the current position of the robot is provided here by calling this service that we have controlled before. Okay, it's a service that is provided by Gazebo, and it provides you with the coordinates of the robot in this Gazebo world. So we have here the X and Y, and then we just compare the distance between that point and the points that we have defining the trajectory. Basically, it says you are closer to this. So one of the things that we can say is here is, let's see, is here is to print, for example, print the, well, actually, it's saying this already here. It's printing this, the closer point. It's here printing. The closer point is which corresponds to the trajectory point 0. Okay, so in this case, it was 0. We go to the shell. 361, 154. That's the position of the robot, and 361, 154. That's strange. No. Okay, yeah, sorry. 4.1, 139. Then that's very close to the position 0. That is correct. Okay, so that it looks like this is being correct. And then maybe what is happening here is just the distance. I also touched this. I don't remember why, but I think I put it is less than distance between the current position and the next trajectory point. If it is lower, so maybe if I increase it, so it will work. So let me check it again. So I have changed that situation. Then I'm going to launch it again. So in theory, should be say 0.0 and then say that it has been reached, because the 0.0 is around here. Okay, so it's not. Let me see. Yeah, so people is suggesting that we use a different point. Yes, that's true. We can do that, but I can tell you that I was testing this and before here, and it should work in an easy way. I mean, so let me launch it again finally. Otherwise, I will leave it. No, but is the thing is turning, okay. Number 0, yeah, but it's not reaching, it's not detecting that it has reached the point, and that's why it continues to turn there. So there is a problem here in the distance. So if we print here the distance, it's not detecting. So we'll see what is happening. Of course, it says 0.9. That's not correct. Okay, so there is a problem here in the distance between that point, because the X pose and the Y pose. So, okay, final test. Okay, so let me check that, and otherwise I will leave it very quickly and very dirty. Yeah, you can visualize. So there is a question, a speedy test, that says if you can visualize the waypoints. Yeah, okay, so here it is. It's saying, yeah. So yeah, it looks like it's correct. Okay. Maybe it's a change in the measures. Okay, let's put it like this, 0.1. Okay. So, okay, launching again. There it goes. And now it goes. Okay, so yeah, so I have modified here just the threshold. At the end, it was just a matter of the threshold that for some reason it's larger than it should be. So now it is working, and then it's going one waypoint after another. I have put a lot of rubbish there, of course, in order to debug. So that's not the point, but you can see that it's selecting next waypoints and going forward towards the different waypoints, okay? So let's continue with the rest of the video. I presume that you will have that. Then if you want to have this modification, please go to the fake navigation.py here, then go to the line 91, and then modify this threshold. That is the one that is identifying when the robot has reached the waypoint. And it was very low. I should investigate why is that, because it's very strange. Okay, maybe it's a mistake. We did it. I don't know. Maybe I was touching myself, so it's before the live class, so it's very likely that it was me. But in any case, there is an error there. Okay, so sorry, it's not line 91 because I have added some prints. It's line 88. Line 88, so where it says distance, then put a 1.0. Okay, now the robot is moving around. You can see that. And let's do something else. Let's go to the Jupyter Notebook now and launch more than one Duckiebot. That's quite interesting because we want to test with more Duckiebots around there. For that, well, you don't have to do anything because we have to use the same ROS launch that we did to spawn the Duckiebot, but we should provide some parameters that is BEH with the Duckiebot name. That's the name that we want to provide to the Duckiebot that we are going to spawn. If you remember, that Duckiebot was Robot1. So in Gazebo, you cannot have the same models with the same name, but also, so that will collide in Gazebo, but also in ROS, if you provide the same name to the same robot, then the topics for controlling it, they will have the same name. Then you have to provide also the X and Y coordinates in order to spawn the robot wherever you want here, in which place you would like to have it. And it is not mandatory. So for example, in my case, I'm not going to express the X and Y. So I'm going to copy this command and use another shell, third shell here, and spawn in a new robot. Okay, so the only thing that I'm going to express is the vehicle name. So I'm going to say robot 2, for example. So as you can see, let me put it bigger so you can see the whole command in a single line. Robot 2. Okay, so it's the same command that we did for launching the Duckiebot, spawn duckbot.launch, and then the vehicle name robot2. And then if I don't specify X and Y, then it will be launched at the default one. That is the same location as we saw here. Okay, so let me launch it now, and you will see how it appears here around here. There it is. So now we have a second Duckiebot. And you can spawn as many as you want. You have to take into account that the more you spawn, oh, sorry, I moved this. So the more that you spawn, then the slower the simulation will run. Okay, so finally, let's go. And every Duckiebot that you spawn, you can start a fake navigation. So how do you do? Well, by launching the fake navigation with the parameter robot name, and then you provide the name of your robot. So I'm going to copy this into the shell. You can Control-C actually this shell. You can see here that the two Duckiebots are on the same location, but I move the robot to the other side so they do not collide. So let me launch the fake navigation with the robot2 robot name parameter. So the second robot should start moving forward. And there it is. So now we have two Duckiebots moving autonomously there in a fake trajectory, so you can test this. So basically that's all for the class of today, because we wanted just to show you the tools that we are able to use for practicing with the Duckiebot project. And the next week, we are going to use this simulation with all these tools in order to train the robot to follow the line. So this navigation will not be fake. It will be directed by the following the lines. Okay, so that is all. So if you have questions, I will be happy to answer. Just remember that if you like this, the class, please give us a thumbs up in the video recording that you are watching. It's very important for us. And then subscribe and press the bell for more tutorials. Remember that we are publishing one new video about ROS every day. One new video about ROS every day. And in case that you want to learn more, we have an academy online that uses this tool, this tool. It's also a web tool. It's online that uses simulations for training you for learning ROS. So you can take some of the basic ROS courses, but we have also many advanced courses there about OpenAI, about autonomous cars, about ROS control, and FlexB, for example, for behaviors with robots, etc. So check that our academy that is called the Robot Ignite Academy, and I have provided here a discount coupon here that you can use it if you want. If you use it before the 19th, then you will get a 7% discount to the academy. Finally, let me tell you what we'll do on the next ROS live class. That it's about, well, what I mentioned, that we are going to follow the lines using reinforcement learning. Okay, so here you have a link to the video, and that is all. Then let me know if you have any question. Jordan says, oh no, infinite loop even after modifying the code. So I suppose that you mean that the robot got stuck at some point. Okay, yeah, we have to debug that code a little bit more. So it's a quick and dirty solution for navigation. So yeah, and it's my mistake that I have been playing with it on the hour before the live class. So probably I did something wrong in the details. Sorry for that. So I will test it for the next live class and provide you with a better version. Okay. Any questions? Any questions? In my case, the robots are there, both of them, they are moving around. We have some minutes before 7, and I can use it, for example, to spawn another robot. What if we launch a third one? So I'm going to close this one. And yeah, so vehicle, Duckietown, Duckiebot name, yeah. So let me put robot 3, for example. Oh, okay. So Jordan says that he didn't save the changes. Okay, that is great. Okay, Jordan, perfect. Jordan, no, sorry, it's German. German. Okay, so any questions? I'm here for a couple of minutes more. There it is, the third Duckiebot in a scene. There it's going, and I'm going to launch also the navigation. There is Jaduna Nandan that says how to find the time of collision if the robot collides with a wall or another vehicle. Time of collision, what do you mean by time of collision? Do you mean the computer time? Or are you talking about the time at which of the computer at which the robot collide, or a prediction if the robot is going to ROS time? Yeah, okay, so you can use ROS time dot now to get the time at that moment, and then you will get the time of the robot of the at which the collision has made. And there is another question by Tluru that says, do you create a waypoint in Gazebo, or are you creating map and making waypoints? No, it's a waypoint. It's just a crude point in Gazebo. So it's a point in the framework of Gazebo. But is this same? Is the same? Yeah. So what I'm getting, let me move this robot, okay, because the other robot is coming and they are going to collide. So let me move it. So, and then I answer your question. Then the position of the robot that I am getting, if you check the code of the in the IDE here, when we get the position of the robot, we are calling a service that is called here. On this service, it's called get model of state. So we call it for the name of the robot. So we say, hey, please, Gazebo, give me which one is the position of the robot in the Gazebo wall, okay? And then we compare this with a set of positions that we have taken into the Gazebo wall also. And then based on that difference, then there is a very, very simple algorithm that computes the velocities of the robot in order to head the robot toward that point. But both of them are based on the Gazebo coordinate frame. Then there is another question, how by Yadunandan says, how to know if two vehicles have collided or not? Okay, so yeah, well, it depends how you want to do it, because so by using Gazebo calls, you can get the position of both, so you can know if they have collided. Also, for example, in this case, there are many, many ways, okay? So if they are very, very close based on their shapes, so you have to compute that, get the positions of both, and then see if their shapes collide or not. That's one way. Another way is to see if the robot, one of the robots, for example, it has an IMU, so you can check the inclination of the robot. So if the robot is not properly inclined, so with parallel to the ground, then it means that has collided against something, for example. Or what else? I don't know, something. Because here we don't have any sensor that detects a collision directly. Those are a couple of methods that I just thought about. Jordan says, how do I define the coordinates for new Duckbot? I don't understand your question. What do you mean? How do you define the coordinates? So in this Duckietown world, there is a wall coordinate frame, and I don't remember exactly where it is. I think it is here in this corner, the 0, 0. So all the coordinates are related in Gazebo, I mean, from that frame. Then every robot has its own coordinate frame, of course. Then this means that every robot has a coordinate frame that consists of the X axis going forward and the Y axis going to the left, and then the Z axis going to the top. So based on that coordinate frame, you can, for example, define the positions of objects related to the robot itself. So it's a relative to the robot frame of reference. If you don't want to provide this into the Gazebo frame of reference, for example. Tricao says, do you have any guide of running these ROS projects on local machine? Yes, actually, there is a video that we have published 2 days ago that says how to use a ROS jet on your local machine. So check for that, and then you will in our channel, and you will see. Then Speedy Step says, is it possible to use Apple Swift programming in language for ROS? I have no idea, but I assume that no. Oh, one question, by the way, Tricao, then why do you want to use this project on your local machine? I'm really interested because here it's so easy to do it. So in your local machine is a lot more complicated. So please, if you can answer that question, that would be very helpful for me. Then Tluru says, I got it, thanks for the explanation, great. Jadunadan, thanks so much, great explanation, okay, thank you. And Jorman says, good, I got it, thank you. Okay, very good. So guys, so ladies and gentlemen, so let me finish here before those two robots collide. Well, I think I cannot stop it right now, so they are going to collide anyway. And if you have more questions or comments, please put it beneath on the comments of the video, and we'll answer the questions for you. Okay, and give us a thumbs up, please, and subscribe. We need that. Tricao, any answer to my question that you can answer me? That would be very useful. Okay, thank you, Jorman. Thank you. Finally, I can. Okay, you are here live. Very good, Jorman. I'm happy for that. Tricao, he says, I will need to run this code for real Duckiebot, and I don't think I can run it with your environment. Okay, that's my guess. Oh, okay, yeah. Well, actually, there is an option, but it's not for free. That option is not for free, but you can use this option that is here. It's called the. Oh, it's not here. Okay. Oh, yeah, because I'm not using a free account anyway. So there is an option here that is the option for connecting with a VPN to your local machine. So you can connect to the real robot from here, actually, and send the code from here to the real robot, or make the code here control the real robot by establishing a VPN. It's an option here. And today I use another account, and sorry, but I don't have the option here. It should appear here. Okay, thank you very much, everyone. And thank you, Tricao, for your answer. Thank you very much, all. See you on the next live class. Cheers. Yeah, cheers. I will continue relaxing myself. Yes. Cheers.